So in this video, we're going to prove why the cosine of 45 degrees is equal to square root 2 over 2. And in fact, it's going to be very obvious from this result that sine of 45 degrees is equal to square root 2 over 2 as well. The only difference is that you take everything in terms of cosine and you just write sine. So it's the same idea right here. So yeah, it doesn't matter if it's cosine or sine. Just know that when you see that 45 degrees, that value is square root 2 over 2. And the reason that this is important is that it's going to allow us to figure out what different values are along our unit circle. So let's get into the proof of it. Now, I don't want you to write this down because I'm going to erase this, but I'm just wanting you to get this kind of picture in your head. Here's a unit circle. Its radius is defined to be length 1. If you're considering what theta would be, theta is just going to be 45 degrees here. So this length right here is 45. This arc length right here is said to be 45 degrees. Now, if I take this triangle here and I drop a perpendicular down, so if I take this triangle and I drop it down, so this is 90 degrees, what I'm trying to do is I'm trying to figure out this length from here to here, and I'm going to say that this length would be cosine of 45 degrees. If I can show that this length right here, cosine of 45 degrees, you know, that's my x-coordinate right there. That's my x-coordinate. If I can justify why that is going to be square root 2 over 2, then my proof will be done. So that's kind of the picture that I'm envisioning in my head right now with this thing. All right. I'm going to erase this theorem over here. Again, it's square root 2 over 2. I'm trying to justify it's that. If I can do that, I'm good. All right. It's just going to give me more room. Proof. I'm going to draw a triangle to look just like it was before. So here's the radius of 1. Here's my perpendicular, and there would be theta right here. So this is theta, 45 degrees. This would be my perpendicular. I don't know what that is. This is my radius of 1. Now, if you consider this to be my hypotenuse, so I'm going to go 1 times cosine of 45 degrees right here would be this side length right here. So if I take my hypotenuse, cosine of the angle that is attached to it, that will always give me my adjacent side. And that's because of projections. So this would be 1 cosine of 45 degrees right here. Now, I'm also wanting to figure out what this length is here. And the reason for that is that I can use the Pythagorean theorem to figure out what cosine of 45 degrees is. So the way I'm going to do that, though, is I'm going to try and figure out what this arc length is here in terms of degrees. You know that the sum of these angles add up to 180. So therefore, this is the symbol for therefore, this must be 45 degrees as well, because 90 plus 90 add up to 180. So we know that this angle automatically is 45 degrees. If we take my hypotenuse, cosine of the angle it's attached to, so 1 cosine of 45 degrees, this will give me my side length here as well. So this will be 1 cosine of 45 degrees as well. Now I'm going to erase the number 1 because it's right there, so I'm going to erase that. So erase that thing. Just to clean things up a little bit. And in fact, so I don't have to write cosine of 45 degrees so many times, I'm going to call that x. And I'm also going to call this x. So again, I'm trying to show that x, this thing right here, is equal to square root 2 over 2. So in other words, if I can show x is equal to square root 2 over 2, I'm good. So that's what I'm trying to show. Now, if you look at this triangle right here, I already said this earlier, but by the Pythagorean theorem, we know that this side squared plus this side squared must equal 1 squared, the hypotenuse squared. Now, at this point, it looks doable. I think I can figure out what x is, and I'm going to try and show that that is equal to that. So, in other words, I have 2x squared right here. So I'm going to write 2x squared must be equal to 1 squared is just 1, so 2x squared is equal to 1. This implies that x squared is equal to 1 over 2. If I take the square root of both sides, I get x is equal to the square root of 1 over 2. And I don't have to worry about the negative possibility here because it's clearly going to be positive. So I can ignore that case safely. In other words, it's going to be equal to, I can break this thing up. I can break up this square root, so it's square root of 1 over square root of 2, which is equal to 1 over the square root 2. Oh, geez, I got a square root in the denominator. I don't like that. That doesn't look good. We don't like square roots being in the denominator in math for some weird reason, but we just don't like them down there. So I want it up top. So I'm going to multiply this value right here times something. What I'm going to do is I'm going to multiply it by square root 2 in the denominator because square root 2 times square root 2 is going to give me 2, which gets rid of that square root problem. But since I did that in the denominator, I have to do that up top as well. So it looks like that. This means that x is going to be equal to 1 times square root of 2 is square root 2. And if I look in the denominator, square root 2 times square root 2 is 2. So I'm done because I showed this right here. And I'm just going to make sure you can see it down there. So right here you see that square root 2, and then square root 2 is going to be 2 in the denominator. So I'm done with the theorem from there. All right. Hope this video helped. It's a very important result.